Here I'd like to help you understand what a polynomial function is. As we work with polynomials, we will see that they can be classified into some sets. And we've been working with some polynomials so far. For example, 2x minus 3. That's a linear function or linear equation, and that's a polynomial. Underneath of that, I just added a 4x squared to it. So 4x squared minus 2x minus 3. Or any other type of quadratic that you can discover, that's also a polynomial. Sometimes we've seen functions that we've worked with that are just constants. So maybe like something equals negative 3. That's also a polynomial function. A very simple one, but one nonetheless. And then lastly, we can set something equal to 0, and that's a zero polynomial, or a zero function. Kind of boring, but it's a polynomial nonetheless. So what do we do if we go the other direction? Instead of just having x squareds, maybe we can have x cubes and x fours. Maybe something like 10 to the x to the 8th minus 6x to the 3rd plus 1. Is that a polynomial or not? Well, it is a polynomial. So let me look through some examples with you to help you identify what is a polynomial and what is not. And then if it is a polynomial, let's determine what the degree of that polynomial is. So over on the right side of my board, I've listed several functions. The first one, f of x, not s, but f of x, equals 2 minus 3x to the 4th. That is a polynomial. And it's a polynomial of degree 4. And how I know that is I look for the highest x exponent. In this case, it's a 4. The second one, g of x. G of x is not a polynomial function. And the reason why is I can rewrite square root of x as x. Remember how to go to exponent world? That's x to the 1/2. And to be a polynomial, your exponents must be non-negative. Non-negative integers. Must be a non-negative integer. And this is a non-negative, not an integer. So therefore, g of x is not a polynomial. H of x, x squared minus 2 over x cubed minus 1, that is also not a polynomial. It possibly could be a polynomial if this 3 in the denominator was a negative 3, because then that would have brought it up to the top. But since this is a positive denominator down here, this x minus 3 will remain in the denominator of that rational expression. And so therefore, this rational expression, and most rational expressions, are not a polynomial. F of x equals 0. Well, that's our boring zero function. And it is a function. It is a polynomial function. G of x equals 8. It's just a constant, but that's also a polynomial function. And lastly, h of x equals negative 2x cubed times x minus 1 squared. I see no square roots. I see no way that something turns out to be in the denominator. Every exponent of my x is a non-negative integer. So this is a polynomial. However though, what is its degree? What's the degree of this polynomial? In order to find out the degree, I need to look at the x and the highest exponent belonging to one of those x's. Well, I have an x cubed here, so is it degree 3? No. I also have an x squared in this term. And this x cubed is being multiplied by that x squared. So x cubed times x squared produces an x to the 5th. So the degree of this polynomial is of degree 5.